ES Audio.
From the Evening Standard in London, I'm John Weeks, and this is The Leader. As you walk through the streets of London looking for lunch, these days there's a plethora of options if you are vegan. Pea protein burgers, soya sausages, plant-based mints, you name it, there's a meat-free equivalent available. But over in Oxford, a startup that launched out of the city's famed university is working on another option for vegans, vegetarians and meat eaters: cultivated meat.
It's kind of the most natural process in the world, is cell replication. And we are essentially fooling those cells to keep replicating.
Ivy Farm Technologies was set up in 2019 with the aim of creating real meat without the need to farm, grow, and ultimately slaughter millions of animals. So, to find out exactly how they've managed it, I went on a tour of their lab. So I'm here at Ivy Farm Technologies in Oxford with Rowan Ribbington, the head of cell sciences here. We are in the lab, Rowan. First of all, where are we? What stage are we at here in the cell-to-fork process?
Yeah, hi John. So we're here in the molecular biology lab, and this is where the beginning of our cell-to-fork journey begins. So, this is where we get the first tissue sample. It's about the size of a dice, 1 by 1 centimetre cube type of thing. And, we break it down with enzymes, we get the cells, and then we're looking for a really specific subset of these cells. So we could get upwards of 40 million, but we only want, 1 to 3% of these. From those 1 to 3%, we've developed this really key, robust way of bringing those cells through, right? And it's great because it means we can grow only the purest muscle and the purest fat cells. So we can grow just the parts of the animal which we want, which are really nutritionally valuable, so not all of those gristly bits which you can find in some other processed meats products.
Amy. Hey Charlotte.
You can see down here, so that liquid shaking around. So in there's tens of millions of cells flowing around, growing, proliferating, and then this is small scale in here, so this is where we learn, really. We do stuff, we learn, we optimize things, we develop medias, we understand how they grow, what nutrients they need, and then what we do is we take them up in scale. Okay, so this is the next part of our process. So once we've taken the exact cell populations we want, so the pure muscle and the pure fat, we go into the next stage of the process. And what we do there is we train the cells. So we stress them and then we train them to grow really, really efficiently outside of the body and make sure that they grow in the right environment, which is key for us to get up to scale.
So Rowan, we're in another room now with what looks like quite a big machine, a glass box with various different elements inside it. What stage of the process are we at here?
So this stage of the process is what we would call media development, and we call media, and really what that is just a liquid feed. So, cells in our body, they just need a basic load of components, really. Protein, lipids, carbohydrates, fats, and vitamins, minerals, and the specific formulation of those is key to how they grow. So that's a really key part of our process, and the machine we're looking at here is what we call a high throughput liquid handler. So it's a robot, and it makes that process really efficient for us, and it enables us to, what we would say, screen lots of different ingredients to make sure that the cells, again, all those really healthy ingredients which make them really nutritious at the end of our process.
Okay, Rowan, so we're now in another room, part of the lab. Looks a lot more sort of kitchen-y, more sort of stainless steel things around and containers. What process are we at here?
Yeah, so this is our pilot plant, and the first thing to say here is welcome to the largest pilot plant in Europe. So we're really proud of this here at Ivy, and before we were looking at bioreactors at 3 litre scales, and here we've got them at 3, we've got them at 20, 50, and all the way up to 600, which is what we call our Big Betty. So that's our terminal end of production bioreactor in this pilot plant. So, I think the key thing here is to say that this whole process is very controlled. It's 100% sterile and really traceable. And that's really key because we know, every individual nutrient and ingredient which has touched our cells right from the beginning of the process all the way to the end, and when it comes onto your plate to try shortly.
And can we go and have a look at Big Betty, as you called her?
Absolutely, sure.
Looks very much like a beer vat almost. Is that what it is, essentially?
That's a really nice way to think of it. So this whole thing, it just looks like a craft brewery, except instead of brewing beer, we brew meat. That's a really good visual analogy for this. So we have the big stainless steel tanks, and inside of them, instead of the liquid and the hops, we've got liquid feed, but it's for our cells, and they're in there and they're growing at a really great rate. And in the end, instead of siphoning off delicious IPA, we siphon off delicious pure muscle and fat.
And what does it look like when it comes out? What's the process of it actually coming out of this vat? Is it something that you have to sort of spoon out, or does it come out in a paste? How does that look?
Yeah, so it comes out in a what we would call a cell biomass paste, and that's done from this machine over here, actually, which is what you would call an ultracentrifuge. So it takes it out and it produces it into a paste, and then our product team then takes that really nutritious cellular mass and turns it into the delicious products we've had. We've made meatballs and geyser and mince and burgers and sausages. So we're looking forward to you trying it.
So it's got herbs infused.
There's a little bit of sage in there.
Dr. Emma Lewis, Chief of Product here at Ivy Farm Technologies, has just cooked me up a Ivy Farm meatball. So I'm going to try it now and see how it tastes. Yeah, it's got a good texture to it. It's actually quite a rich taste. It does taste real, which is weird to say because I don't eat meat. So Emma, first of all, cooking with this kind of meat, this cultivated meat, how do you find it? Is it different at all to regular meat or plant-based products at all?
It's exactly the same. So as you heard, it sizzles in the pan. It takes roughly the same amount of time to cook. It browns beautifully. And the aroma as well in the kitchen is exactly like you would with a traditionally reared meatball.
And I understand you cultivated this particular formula. Mm-hmm. It's not 100% meat, because not many meatballs are. What is in this particular formula?
Yep, so we've got over 50% cultivated meat, and then the rest is we've got some onions in there, some garlic, some sage, pepper and salt, and then also a little bit of plant protein for structure as well, which brings some bites and helps us commercially with the cost as well.
And how do you find that balance of trying to create these different inventions, really, the perfect formula?
It's trial and error in the kitchen here. We also play around with our muscle and fat proportions as well to get that perfect consistency in the mouth, that mouthfeel that you're looking for, because the fat also brings that kind of succulence, juiciness, moisture to the product. So, a little bit of chefmanship, culinary skills in the kitchen.
Let's take a break now. In part 2, we'll hear from CEO of Ivy Farm, Richard Dillon.
So for cows, it's around between 50 to 25 calories in, plant calories in, to get one out. And that's just crazy, right?
So Rich, thanks for having me here at Ivy Farm Technologies in Oxford. It's quite an interesting concept in general, what you guys do. Meat that essentially a vegan could eat. We're in Veganuary at the moment. What can you tell us about how your product could be on the shelves in future?
Well, look, I think vegans and vegetarians have their own reasons for, choosing that lifestyle and what they consume. And I think there's maybe 4 main reasons. One is animal welfare. People have seen documentaries of how bad industrially farmed animals are treated. The next one's probably the planet and the pollution and the amount of resources it takes in animal farming. The next one may be human health. They just think that meat's not good for, their particular dietary requirements. And then there's maybe a philosophy around, just not using animal products at all. I think if it's the first 2, animal welfare and planetary reasons, then potentially cultivated meat, could be a solution for vegetarians to actually come back to meat, because we don't need to kill or industrially farm a lot of animals. And the burden on the planet is drastically reduced, up to 90% in the technical studies that we've done.
So when it comes to vegans, vegetarians opening their minds up to real meat but cultivated meat, one thing on their mind will be, okay, this comes from animal cells. Yeah. What is the process? Are animals harmed at all? Can you describe to us what that process is?
So the process is actually quite simple, but that all starts with a small sample of cells from an animal. Now, there's different ways that you can get those cells. So, for example, if an animal dies naturally, let's say in the birthing process, you can then take a sample quickly, just after death. Or you can take the sample from a live animal. Or you can take cells from animals from either research farms. We've got some agreements with veterinary colleges and agricultural universities. Or the final one is, meat that's actually bred for slaughter. But once we take those cells, this is the magic part, we have the technology to identify the cells within muscle and within fat, which are called primary stem cells. They have the ability to repair tissue and keep replicating. And our technology essentially allows those cells to feel comfortable being outside an animal, in a tank, and just keep replicating itself. It's kind of the most natural process in the world, is cell replication. And we are essentially fooling those cells to keep replicating, which means you don't need to go back to an animal. So from a vegan point of view, I think it's a beautiful thing. There's a cell bank that's produced, and you don't need to then go back and either harm or even farm an animal to keep producing batches and batches and tons of pure muscle, pure fat, which you then put into to make a final product. So in a nutshell, cells from an animal, small number, identify the ones we need, grow them up in a series of tanks until you get to a terminal fermenter, a large-scale reactor, which you would then harvest from and make the final product.
And I saw you at a talk recently where you were talking about the impact of industrial farming on the planet. Yeah. So quite stark figures around that. Can you tell us what you were saying about that and how much of an impact it has comparable to other sources of carbon emissions, for example?
Yeah, that's a good question, John. I think a lot of people inherently think, okay, I've heard that animal farming's like not good for the environment, but just the scale of the problem is huge, and most people are not aware. So the way I like to think of it is there are three main industries contributing the biggest amount of greenhouse gases. So the first one is energy, and that's about 30%, something around that number. Then most people think, well, it must be transport after that, because they hear a lot about Teslas and changing the way they get around and maybe flying less. But actually, the second biggest contributor by a long way is animal agriculture. Agriculture's, up there in the, late 20s, 30%, and the biggest part of that is animal agriculture. It's about 18% of all greenhouse gases. So if someone wants to really make an impact and their own personal kind of carbon footprint, actually they would be better giving up traditionally farmed meat than trying to save up and buy a Tesla and reduce the amount of petrol that they're putting into the world. And that's quite a big kind of reality shock for most people. And then to put it into context, the reason why animal agriculture is so damaging is that effectively animals are quite inefficient at turning plant proteins, or plant calories, should I say, into flesh, so into animal protein. And that's the reason why you need so much land to farm animals. But the biggest use of land in all of agriculture is farming plants to give to animals to then turn into meat. So they eat it, they do the digestion process. So for cows, it's around between, depending on which study you look at, between 50 to 25 calories in, plant calories in, to get one out. And that's just crazy, right? Pigs, it's about 15 calories in to get one out. And I think chickens of the major kind of meat sources would be the most efficient, around 7 in to get one out. But still, in any other industry, would you spend $25 to get one back? It just doesn't make sense from a use of resources. But because people love meat, they love the taste of it, they've grown up with it, it's kind of in the tradition, then people don't want to give that up. But from a use of resources point of view, it doesn't make sense. So that's why we're really excited about cultivated meat. It can produce the same end product, and we're looking at between a 2 and 3 to 1 ratio. So 2 to 3 calories in to get one out, which is a much bigger saving.
And obviously you are making the product. You've got to a point where you have something that you can produce, that people can eat, that I've tried, that I've eaten. Why isn't this in restaurants across the UK, across the world? What's the barriers? Why isn't it there yet?
Well, it's almost there. That's the good news. So I think in Singapore there's a chicken product out there in a few restaurants. But basically the whole industry is still at pilot phase. We've got to go through regulation and at the same time go on that scale-up process to get the cost down. If we get regulated we'll give our dossier to not only the UK FSA, but we'll do it to a few jurisdictions around the world. If we get regulated soon, we will start selling our pilot plant products. They'll probably be at a loss because the cost is still quite high because we're in small scale. But then you could see a few restaurants with our products in. I think that's the real start of the education journey then, and making it believable for people that it's not science fiction, it's real.
There's more news in the Evening Standard newspaper and at standard.co.uk. That's The Leader. Thanks for listening. We're back tomorrow afternoon at 4 o'clock.